Let's dive into the mesmerizing realm of the Penrose Triangle. This impossible object, first created by the mathematician Roger Penrose, defies the laws of physics. Its form seems to loop back onto itself, creating an endless triangle. Yet, when you attempt to construct it in three-dimensional space, you find it's an impossibility. The Penrose Triangle tricks our brains because we're wired to interpret two-dimensional drawings as three-dimensional objects, and this triangle exploits that inclination to its full advantage. Next on our journey, we encounter the Muller-Lyer Illusion. Two lines of equal length, each adorned with arrowheads, suddenly seem unequal. The line with the inward-pointing arrowheads appears longer than the one with the outward-pointing heads. Why does our brain get bamboozled by this illusion? The leading theory suggests that our brains are trying to interpret these lines as three-dimensional objects, and the arrowheads mimic perspective cues, causing us to misjudge the lengths. We now cross paths with the Hermann grid illusion. This illusion presents us with a grid of black squares separated by white spaces. Yet, our eyes insist on seeing ghostly gray blobs at the intersections when we look away. This illusion occurs due to the response of the neurons in our visual system, which are more stimulated by the white spaces than the intersections, creating the illusion of gray spots. Lastly, let's delve into the fascinating Ebbinghaus illusion. This illusion consists of two circles of the same size, each surrounded by other circles. One is encircled by larger circles, and the other by smaller ones. The circle surrounded by larger circles appears smaller than the one surrounded by smaller circles. This illusion happens because our brain uses context to determine size, and when the context changes, our perception of size does too. In conclusion, optical illusions are a testament to the complexity and intricacy of our visual system. They exploit our brain's tendency to interpret two-dimensional images as three-dimensional, the way our neurons respond to different stimuli, and even how context influences our perception of size. Therefore, they serve as a gentle reminder that our perception of reality can often be a sophisticated illusion. We are not just passive receivers of our visual environment, but active interpreters, constantly constructing our reality. So, the next time you find yourself entranced by an optical illusion, remember, it's not just a trick of the eye, but a glimpse into the fascinating workings of your brain. And may you always be reminded to question what you see, for in the realm of perception and reality, not everything is as it appears.